Yes, children, the C part. Simple applications for refraction of light. You know, in A part, we have already done the refraction, the lateral displacement, the cause of refraction, factors affecting, so many fundamentals regarding refraction that takes place at plane surfaces we were working. Which were the plane surfaces that we were doing? Water keeps its surface as level, that means plane surface. Glass block we were considering. Okay, glass and water, and also diamond was considered for the refractive index and speed of light in that medium. Okay, now we are considering the applications. Due to refraction, certain consequences are happening, and some of the information that we received by learning the A part, we will apply into our life. Look at this example. A person who is standing in water and wants to catch a fish inside water. Okay, you study, just go through this diagram. And like ancient time, people used to do this way, no? They used to fish by using spear or so. So he wants to throw it to the fish, so it has to strike on it, so it can be caught. That is what he wanted to do actually. So only a well-trained or an experienced man can actually reach the tip of the spear onto the fish. If not, that means the consequence of the refraction, the light bends when it enters from water, when it enters into air, it bends away from the normal. They don't study physics as such, but by experience, thinking that where he observes the fish, if to that direction he throws, it will not reach to the fish actually. So that is by experience. Next time he may try with a different angle. So by a calculation, such persons know how to catch it, how to aim it correctly. So let us now work it out by diagrammatic method. Where is the actual position that we see? The actual position in water is at a position. The fish is where I have marked it as in red color. So I drew the fish in red outline. So let's consider how to explain this. We are considering a ray of light which is coming from the fish towards the surface, towards the man. So this is the ray, the red one which I've drawn here is a ray of light which is coming towards the surface of water, and therefrom it will bend away from the normal. Yes or no, children?
Yes, ma'am.
Yes, maybe from the eye. Where is the eye? Or on the head, where the eyes are there, one eye. I've just drawn a ray of light here. So this ray of light, as it reaches to the surface of water, that is water-air boundary, when it reaches, we know when you draw ray diagrams, at the point of incidence, we have to draw a what is called normal. So it's already drawn and kept. You can see this is the normal. From the normal in black, dotted lines are drawn. From the normal, the actual course of the ray will be bending away. That is, into a rarer medium, it is incidenting. So it will bend away from the initial direction as it was coming. Yes or no, children?
Yes, ma'am.
As we know, the person's upper part of the body is in air and the fish is in water. Water is a denser medium. From a denser medium, when the light enters into a rarer medium, what happens? The path of the ray will be bending away from the normal. Yes or no?
Yes, ma'am.
I'm just keeping this ruler, you see the way that I'm tilting. It is tilted. Now, how much it is to be tilted, I'll teach you in that diagram where the apparent bending of a stick we will work. Okay, so at present, the ray of light is bending in this direction and is reaching to the person. Yes or no?
Yes, ma'am.
The ray of light is now entering into the air and it bends away from the normal and reaches the person in this direction. Okay, so it reaches here at this direction, it is reaching, and the person can visualize the light. And even when we see, when certain rays of light are reaching to our eyes, straight backward, we imagine, we can perceive the object, the real object, just at the back side of this the refracted ray that is reaching to our eyes. So what the person perceives is not in the actual path, but when we reproduce, when we produce backwards the ray which is reached to him, he thinks the fish is at that place. So he feels actually this fish is corresponding to this point. Now, till where this dotted line is to be drawn? Vertically above the object. That means in this case, the fish. So fish, where was it? The reason why is we are taking actually two rays. One is from the eye obliquely to reach. The other is normally. Suppose there was another ray, which one more ray. There are so many rays from one point it is coming out of which one ray, the red one that I have drawn, which is refracted towards the man. And another ray, suppose, was moving in this direction, normally to the surface. And you know, any ray that is incidenting normally to the boundary of two transparent media, then it goes undeviated. This is the second one. So the second ray goes, that means it was incidenting this way and it goes undeviated. And if the person's vision is in between these two, that means these two refracted rays in between, if the person is viewing this object, whose image will be seen to be formed in the intersection of these two refracted rays. When the two refracted rays, the vertical one and the oblique ones, are reproduced where they meet, he feels, we can perceive, our retina forms it this way. So any ray that is reaching to us, when produced backwards, first ray and the blue one, which is the second ray, is producing backwards. So the fish whose eye will be somewhere at this place. So the person sees the fish to be at this place. Can you understand?
Yes, ma'am.
In actual practice, it was bit lower, but the person feels it is little shifted upwards. Is it fine?
Yes, ma'am.
So such a person, once if he had tried at where he sees, that means towards this direction, if he does, it will not be caught. So by practice, he will tilt towards some distance. By experience only one can do so. Actually, where he sees, suppose here he sees, below that he will direct so that it will reach to the fish. Is this point clear, children?
Yes, ma'am.
How do we make use of, what do we have to learn from this? We have seen the actual depth of the fish is till that red outlined fish, isn't it? So from the surface of water, the actual depth is from here till here. This is called real depth. In reality, this is what is the real depth. Yes or no?
Yes, ma'am.
And the fish is shifted little above. So the apparent depth means, apparently means what he is feeling like. It is only at this much depth he is feeling. So this is called apparent depth. Apparent means what we can feel. Apparent depth. So I am writing two words. One is real depth. The actual distance from the surface of the liquid under which an object is, and what we feel like seeing, sensation, that is apparent depth. So two different depths are mentioning. So suppose in this case, the real depth is suppose 4 meters. And the apparent depth, definitely it is less than that, children. Suppose you consider this is 3 meters. Okay, if considering real depth is equal to 4 meters from the surface and the apparent depth is seen to be suppose 3 meters, we can say there is a shift occurred from the actual position to the observable or apparent position. So this distance between the real depth and the apparent depth, that is what is called shift. So three new terms we are learning. What is the shift and how can it be calculated? How much it is shifted? From 4, it is shifted to 3. From the surface, total 4 meters were there and it is come to 3 meters, means 1 meter it is shifted above. Yes or no? So shift
Yes, ma'am.
by the real depth minus apparent depth. Okay, real depth minus apparent depth. In this case, we can say 4 meters minus 3 meters. 4 minus 3, which is equal to, in this case, it is 1 meter. Yes or no? So in general,
Yes, ma'am.
any object we see underwater or any denser medium, it is felt little raised above the actual position, actual depth. Yes.
Yes, ma'am.
This phenomenon, this apparent depth is not actually the real depth, it is slightly lesser. This is due to the refractive index of that medium. So this difference in the real depth and apparent depth is due to, this phenomenon is due to the refractive index of that medium, that is the denser medium. Note down. But symbolically, you can draw a diagram and the three terms. This is suppose, I said, suppose if the real depth and apparent depth, if I'm taking so, the shift is this much, I say. I wanted to show the relation between them. And how is it now related to the refractive index of that medium? We know the denser medium is water, and the absolute refractive index of water is actually mu W with respect to A, absolute refractive index of water. This is related to the real depth and apparent depth in this way. Whatever is the real depth divided by the ratio of the real depth to the apparent depth gives you the refractive index of the second medium, that is the denser medium. Do you understand? In this above
Yes,
example,
ma'am.
real depth, if it is 4 meter and if it is apparent depth is 3 meters, then 4 by 3, which is equal to 1.33, which is the refractive index of water, you know?
Yes, ma'am.
Yeah. 1.33. Not done. So from this, we are learning two relations. Shift produced is equal to real depth minus apparent depth. And refractive index of the medium is equal to real depth over apparent depth. These two relations you learn. And always, when we view from a rarer medium to a denser medium, the real depth will be more and the apparent depth will be less. Yes.
Yes, ma'am.
Completed. Actually, in your book, this diagram is drawn, the first diagram in page 88, that is two rays are drawn and it is just obtained, the image is obtained just vertically above that, that's it. So I just put a practical example like a fish underwater, how it will be seen by a person who is looking from air, isn't it?
Yes, ma'am.
Now we have to come to the definitions of these three terms. Which are the three terms? Real depth, apparent depth, and shift. Read through the book, children. First paragraph. An object placed in a denser medium when viewed from a rarer medium appears to be at a depth lesser than its real depth. This is because of refraction of light. Yes?
Yes, ma'am.
Yes, ma'am.
And the actual depth of the object under the denser medium is called the real depth, and the depth which we feel, that is little raised above the actual object, that the actual, or we say the depth that we sense, that is called the apparent depth. Yes, the explanation is given after that. No derivation is required. Yes, and the relations
Yes,
are.
ma'am.
Okay, come to page 89, in which the shift of the object. Shift we have calculated real depth minus apparent depth. Now, shift produced is depending on different factors. One is the refractive index of the medium. If the denser medium is having a greater refractive index, it will give a bigger shift. Okay, more the refractive index, more is the shift produced. Number 1 point. Second, the total depth, that means the total thickness of it, that also matters. So look into the book. You can learn it from the book, page 89, I suppose. Can you see the shift by which on the right side?
Yes, ma'am.
Check if it's or not.
Yes, ma'am.
The shift by which the object appears to be raised depends on, number 1, the refractive index of the medium. Second, the thickness of the denser medium, and the color or wavelength of the incident light. Okay, on which we have to discuss. Hello. Factors affecting the shift produced. First factor is the refractive index of the medium. Yes, first one.
Yes, ma'am.
This is directly proportional, children. More the refractive index, more is the shift produced. Okay,
Yes, ma'am.
words instead of directly proportional, you can write it is more the refractive index of the denser medium, more is the shift observed. Okay, second one is the thickness of the second medium, or we say denser medium. This is also directly proportional. Thickness of the denser medium. Means consider this is a glass block of thickness this much, and we have another glass block which is with some more thickness. If you are taking two glass blocks of different thickness, if you want, we can keep the length the same, only thickness the difference I'm keeping. Thickness is different, I'm keeping.
Yes, ma'am.
Yes, ma'am.
Such two glass blocks we are considering, and view the same object below it. Suppose we are keeping an object here, maybe a red piece of a small piece, maybe a cloth or something we are keeping, and exactly the same size object we are keeping below at the lower side of the glass block exactly the same. The shift produced will be more in the second case, the one which is having more thickness. Do you understand?
Yes, ma'am.
Yes, ma'am.
More the thickness, more will be the shift produced. That's the only point you need to understand here. Third is the wavelength of the color. Third point, it's written the color or wavelength of the incident light. The color, you know, different colors have different wavelength, children. You know, not with Georgia, violet has got
Yes, ma'am.
4 nanometers.
Yes, ma'am.
Yes, ma'am.
And red has got 800 nanometers, and all the rest colors are in between, intermediate wavelengths. Okay, the wavelength, or we can say color of the light. Here, you need to understand the wavelength of violet, mu. I'm saying the refractive index, I'm telling. We know the refractive index of violet. This we already studied in A part. Refractive index of violet color. That means the bending produced by the violet color. That's what's the meaning. Violet color is more than the refractive index of the red color. Within a medium. Okay. So we can write mu V. Refractive index topic, we did this, children. Refractive index, the factors affecting refractive index ke under. Do you remember?
Yes, ma'am.
Yes.
Yes, ma'am.
So which you are applying here, that's it. So how can we symbolically write? That is mu V is greater than mu R. Because the wavelength of R is more, the wavelength or refractive index inversely proportional. Yes. That is
Yes,
lambda V is lesser than lambda R. Lambda means the wavelength, children. Okay, to depict this, I'm taking you to an example. Please look at here, children. It's a glass block under which I have written 7 letters with their own colors, the Vibgyor colors. You know what are Vibgyor colors?
yes, ma'am.
Violet, indigo, blue, green, yellow, orange, red. Okay? So 7 colors, the letters corresponding to the colors written on their own colors are kept under a glass block. Suppose this is a glass block. Under this glass block, I'm keeping the 7 colors and viewing from the top. From the above upper surface, I'm looking from air. We have just now we have seen that any object will have a shift. Seen with a shift we have seen. Okay, so all these letters will be feel like shifted, little raised. Children, if you have any glass block of this kind, most probably you will have a what is called paperweight at home. So made of glass, heavy paperweight, maybe round, spherical or so. So take any such glass object which is heavy and place in your textbook where written contents are there. Okay, and view from the top, you will see the letters outside, maybe above, below, top, bottom, left and right side of this glass block. If you see, they will be seen as how you used to see, but through which when you see, you can see the same sentence part will be raised. You can see this is what is a shift actually. Okay, so if these 7 letters with their own colors, if we are viewing from this, what would be the observation? Can you imagine, children? Can you just guess how will they be seen? All will be raised. This I'm giving you for sure. All the 7 colors will be found raised from its base and a little shifted above. Any guess?
Ma'am, the violet color will be more near to the normal.
Yes, we will see the letters raised, and that means shifted from its position. As we said, that is true. Suppose violet color is seen shifted here, this much. The red will be seen less shifted. Violet will have the shift more because the mu for violet is more. The refractive index, more the refractive index, more is the shift. We studied already. Yes or no?
Yes, ma'am.
And we know violet color's refractive index is more than that of red color, and all the rest have the intermediate ones. Suppose if you see the V shifted to this much place, the R will be shifted comparatively to a lower height. Only maybe R seen in here. Only this much it will be seen. And all the remaining letters will be in between. In between means you can just make yes or no. The rest of the letters also will be shifted from their original position. Shifted means look like, apparently seen, but they will be seen in this manner only, in this line only. They all will be seen. They will be shift, but shift produced will be different for different colors because their what is called wavelength are different. Okay, so you may be seeing them within this range only. I'm just making a mark of them so that under which you can see all of them, within which you can see all of them. Yes.
Yes, ma'am.
I gave only the end ones. Children, once this question was asked in the board, but not the diagram this way to show you. They were only writing the text. I mean, if 7 colors of Vibgeo are written and kept under a glass block, what would be your observation? Which color will be shifted or raised most and which is least? Give reason. This was a question. Do you follow?
Yes, ma'am.
Yes,
Okay.
ma'am.
So these 3 factors have discussed. Now, examples under these 3 conditions. The third condition I'm reading from the book, you can go through. Dependence of wavelength or color of light. The shift decreases with increase in wavelength of light use, since mu V, mu violet is greater than mu red, refractive index of red. Therefore, the shift is more for violet light than for the red light in the given medium. I'm talking about 2 things. Speed of violet is less, so its refractive index, bending, is more. Okay. Examples. For glass, absolute refractive index is 3/2. Therefore, the thickness of glass slab appears only 2/3 of its real thickness when it is viewed from air by keeping the eye vertical above the slab. Same way for water, only 1.33, that is 4/3 times. The mu for water, absolute refractive index of water is 4/3. Therefore, the depth of a water pond appears 3/4 of its real depth. Suppose 4 meter deep water, we feel it's of only 3 meter depth. In the consequences, we have this to be discussed, children. Yes.
Yes,
There
ma'am.
are some 6 to 7 consequences or applications given on the next page. So please follow that. On the next page, we have apparent bending of a thick or of a pencil or a stick we have to do. And this is mentioned in the syllabus. So properly we may have to work on it. Okay. This one, apparent bending of a stick. Neatly you may have to draw and learn. Just in 2 examples we have seen, in the previous 2 examples, children, we have seen that a fish, the eye of the fish was shifted vertically above to certain place, and hence each part of its body, not only the eye, the rest all parts till the tail portion, mouth till tail portion also corresponding. We didn't draw all the lines, no, we drew only 2 rays from the eye itself. So where it will be seen, we have just focused, we just identified. Suppose an extended object we are considering, from all its parts, numerous rays are coming out. They all undergo refraction. Corresponding to the ray, it is coming to which angle it is reaching to the person, the corresponding to which, when produced backwards, we assume that part of that object is. So this phenomena, if you apply to a stick, this is a stick. If you place a straight stick in water, how do we feel like seeing it? The part which is inside water, till then it will be seen straight, but inside water, the part of the stick will be seen bent. This phenomenon we can explain due to refraction of light. How? Consider consider the stick is kept here. It is X and the point at this place, it is P. P is the tip of the stick inside water. Okay. Consider two rays are coming out of it. Because to obtain an image, we need minimum two rays. In class 9's reflection chapter, you have studied it, children. Obtaining a point object's image and an extended object's image you have drawn and learned also. So minimum two rays are needed. Only then when the refracted ray produced backwards when intersect, we can obtain the images formation, the point. Yes. So one of the rays you are taking obliquely to the surface, PQ is one of the rays which is beginning from the tip of the stick underwater. This undergoes refraction, so bends away from the normal in this way. And secondly, from the same point P, one more ray is incidenting to the surface. But remember, the angle of incidence will be different. Because at two different places, normals are parallel, so angle of incidence is different. So angular refractions also will be different. So the two refracted rays under consideration will get away. They will go away from each other so that when they are produced backwards, we feel they are coming from a point P dash. Remember, this point should be vertically above the point P under consideration. So in order to get a fine diagram, the correct diagram, children, this precaution you have to keep in mind. And how will you know where will the P dash be? To know that, what you have to do, I'll give a tip for you. With that, we'll stop today's class. And I'm just taking, okay. Taking the ruler to show you how to draw this. So the first orange colored ray I'm taking, it is coming to incident on the surface of water in this direction. Yes, children? Say yes.
Yes, ma'am.
Yes, ma'am.
From it has to bend away from the normal. This much you know. Suppose by roughly you are making this much only is the bend, or something more is the bend. Remember, when you produce back the two rays, you will not get a point which is vertically above. So before even doing this, what you have to do is, where the point P, we had a point P, one point we are discussed here, this was point P. By assuming vertically above that, you choose a point. Here it has to be the meeting point of the two refracted rays. You should keep in mind where it should be vertically above the P. So place the scale right above, or assume just above that, this much shift above. Okay. So choose a point P dash to which your refracted rays you want to back produce. You should remember. This is a trick to get it. Okay. So if you are having the incident ray in this way, and you know you want to refract it, so keep the scale in such a way that whose lengthwise, when we produce it backwards, it will touch on this P dash which you have already chosen. Could you get it?
Yes, ma'am.
All of you are getting or not? But I'm telling, I'll draw.
Yes, ma'am.
Initially, what we do is only drawing this refracted ray. But to which angle you have to refract, bend, you keep the scale in such a way that which on producing backwards, the chosen P dash it has to reach. So the scale should touch the P dash, keep it. Okay. Then only you will get the correct diagram to get the full marks, I'm telling. So is the same way, the second ray from the same point P, we are getting PR is the ray, which on refracting also you keep the refracted ray's direction so that in such a way so that on producing backwards the same P dash it has to reach. So obtain the P dash there. So when you are asked to draw such a diagram and the P dash is not vertically above that, you will be reduced with 1 mark. Remember. Secondly, if arrows are not drawn, then also 1 mark will be reduced for the diagram. Is it clear to you, children?
Yes, ma'am.
So the incident ray, the refracted ray. So we have another set which is in green color. 2 different colors are shown. When you are drawing, you cannot use colors. Then what do? You will put double arrows. You know it now? In order to show this is the second ray, you will show 2 arrows. This corresponds to the second one because you are drawing it with pencil. Yes or no?
Yes, ma'am.
Yes,
So
ma'am.
Yes,
in this
ma'am.
case, what you are saying, the point P is vertically raised upwards. So why not if there was a Q, this will be vertically upwards. Why not if there is an R, it will be vertically upwards. So each point in this stick within water will be seen to be vertically raised above, and when it is seen in continuation, we will see the part of the stick is bent from the surface till its bottom. Yes or no?
Yes, ma'am.
Yes,
ma'am.
Yeah, this is what you have to draw, learn, and we'll continue next day.